Okay, the reason I need you to copy down these two quadrilaterals is because we need to talk about identifying corresponding parts. Because in order to prove triangles are congruent or not, you need to be able to identify the corresponding parts. And so we've talked about this before, that if you're claiming that two objects are congruent, you're saying that they're the exact same size, the exact same shape. So I think the example I talked about last class on Wednesday, almost 2 weeks ago, was that if we're talking about Ford and the assembly line, and we've got two brand new F-150s come off of that assembly line, on the outside they look absolutely identical, and we would say that those two trucks are congruent, same exact size, same exact shape. However, we're also, by saying that the holes are congruent, we're also claiming that all the little parts that make them up, like the pistons and gaskets and nuts and bolts, all the things that are corresponding that put them together, all those small parts are also congruent, meaning the exact same size and the exact same shape. So, if I'm saying that these two quadrilaterals, that the holes are congruent, well then we also need to be able to identify what the corresponding parts are and then write new congruent statements stating that those parts, the individual parts are congruent as well. A more tangible, I guess, example would be these markers. Although different colors, they're the exact same size and shape. So a corresponding part would be like these caps. These caps are corresponding with one another. These parts are exactly identical. They are congruent. So I'm not saying that all of the parts that make up these markers are the exact same size and shape. Like, obviously, the caps are a completely different size and shape than the actual markers themselves that we write with. But the corresponding parts are the exact same size and shape. Really quickly, just naming other polygons. We've named a lot of geometric objects. And some of those geometric objects involve using 3 letters. Give me a geometric object that we have named in this class that we use 3 letters to name those objects. Angles. Okay, angles, we can say, hey, there's angle BAD. And so, but we have to put that symbol in front of it to say to the reader, to our audience, hey, we're talking about an angle. That's the geometric object. Heard someone else say another geometric object that we use 3 letters to name. A plane. Okay? So we have a plane that we use 3 letters to name, making sure that those 3 points are non-collinear, but we've named planes and we've used the appropriate notation. What about another geometric object that we've used 3 letters for to name? You got an angle, got a plane. There's one more that we've been using. A triangle. Very good. Okay, so triangles as well. So when since we have a lot of different objects in geometry that we use 3 letters for, we have to put that notation in front to tell our reader, hey, we're talking about an angle, we're talking about a plane, or we're talking about a triangle. Once you get past 3 letters, so 4 and above, there's only one thing we could be talking about. The only geometric object that we're going to be talking about in this class that has 4 letters or 4 vertices are quadrilaterals. Now, we don't know if that quadrilateral is a square, rectangle, rhombus, trapezoid. We don't know anything about the specifics, but we do know that it has 4 vertices and 4 sides. So notice that this is not a typo. This is a legitimate congruent statement. It's stating that these 2 quadrilaterals are the exact same size and shape. We just don't need some symbol in front of those 4 capital letters. If I wanted to talk about a hexagon, let's say I had some hexagon and I wanted to refer to it, well then I would just list out whatever. Oh, can't have the same. Sorry, I'm just random letters. L sounds good. So if I write 6 capital letters with no spacing, we would read this as hexagon AEDBCL. And this would be an appropriate name for a hexagon. So whenever you see 4 or more letters really close to one another, it is talking about a polygon with that number of sides. So here we go. We have quadrilateral ABCD that is congruent to quadrilateral EFGH. And here is a picture of them. Now, at first, I'm going to use different colors. I suggest that you use different colors as well, because I wanted to make it evidently clear which parts are coming from this quadrilateral that I've outlined in black ink, and then this one in blue ink. And then I'm going to compare them using a different color. So if you'd like to do that as well, please go ahead and do that. So this whole object, this whole quadrilateral is made up of different parts. You've got sides. There are sides that we can refer to of this quadrilateral. And also it has interior angles that we can refer to. Let's start off with sides. How many sides does this one quadrilateral have? 4. Not a trick question. But we're going to have to name them appropriately. Meaning using correct notation and making sure that the letter order is correct or appropriate, I guess would be a better word. So, what geometric object are these sides? Are they rays? Are they points? What could we refer to these to? Segments. There's a clear beginning and a clear end. This is a portion of a line, so we call these line segments. So notation matters. That means segment, and I'm going to go ahead and list off segment AB first. This is one of the 4 sides. I'm going to keep going. Segment BC and segment CD, and then the last one would be segment AD. Now, am I forced to call these 4 segments segment AB, segment BC, segment CD, and so on and so forth? Or is there another appropriate name for this side of this quadrilateral? What else could I have called it? Could have called it segment BA. Okay? So I just want to make sure that you're all aware of that, remember it, that we could call this geometric object the same exact thing. We could call it segment BA. Now, we've got our sides. Now we have to look at the 4 interior angles that make up this quadrilateral. So I have angle A is referring to this angle, and that's okay, and it's appropriate for me to call it angle A because there's no other angles in this diagram whose vertex is angle A. There's only one angle, it's this guy right there. If there was another angle with that same vertex, I would have to revert to the 3-letter process. But in this case, it's A-OK. And we can keep going down. It's an angle B, an angle C. I could call this angle D, but I want to mix things up a little bit. I'm going to use the 3-letter process to refer to this angle right here, angle D. I'm going to use a 3-letter process. So if I want to refer to this angle right here, I start off at this point A. My middle letter is the vertex, and then the 3rd letter is the other point on the other side of the angle. So I've got angle ADC. Now just like these segments, am I forced to call this angle ADC? Well, obviously not. We just talked about how I could call it angle D, just with 1 letter. But is there a 3rd name I could have called this angle? I could have called it angle CDA. Okay, so we're not limited to just one way we can name these parts of these quadrilaterals. But what does matter is when we start identifying corresponding parts on the other quadrilateral. Because letter order matters. And I need you to write that right here. Above where you wrote that congruence statement, because this is stating that 2 things are congruent, so congruent statement. Wherever you wrote that in your notes, above it, I need you to write, when dealing with congruence, when dealing with congruence, letter order matters. Letter order matters. And our congruence statements, so this guy right here, tells us not only that these holes are congruent, but it also identifies the corresponding parts for us. This congruent statement tells us exactly which angles go with which angles, which segments go with which segments. All of these parts are identified for us because letter order matters. We chose to name the first segment of our we'll just call this the black rectangle, or the black quadrilateral. We chose to list off this segment first, which happens to be the first and second letter of the quadrilateral's name. Well, the segment, or the side that's corresponding to segment AB in this quadrilateral is also the first two letters, because letter order matters. And so it tells us that segment AB is corresponding to segment EF. The next segment is segment BC. That's the second and third letter of my first quadrilateral's name. It's these two. So letter order matters. So when I identify the corresponding part, it needs to be the second and third letter of the other quadrilateral's name as well. And then CD, this is the third and fourth letter, so segment GH is corresponding. Letter order matters. Now, before we talk about segment AD, I asked you, did I have to call this segment AD? No. What else could we have called this same exact geometric object? Could have called it DA. Well, if I had stuck with segment AD, meaning the first letter and the second letter, the first letter and the last letter, I would have been forced to call the corresponding segment EH, because letter order matters. But if I switch, and now I call this segment DA, I am now forced to name the corresponding segment appropriately, meaning HE. Letter order matters when you identify these. Let's go through these angles really quickly. Angle A in this first quadrilateral is corresponding to what angle in that one? Angle E. Angle B is corresponding to what angle? Angle C is corresponding to what angle? Angle G. Now, we know that angle D is corresponding and congruent to angle H. I know that. But we chose to name this angle D with using the three-letter process. So you must match not only the technique, because we chose to name it using three letters, but we also have to match the letter ordering. So, this angle ADC, it must match up. So what letter goes with A? E. So you must lead off with that. The vertex D is what letter over here? H. And then C is corresponding, matching to G. So all I've done is just identified the 8 parts of this first quadrilateral and identified the corresponding 8 parts in this. But this is a congruent statement, and it's stating that those two quadrilaterals are the exact same size, the exact same shape, as wholes. But remember, I said that if you claim that the wholes are congruent, then you're also saying that all of the little parts that make up the whole are congruent as well. Those corresponding parts. So if they told us that the wholes are congruent, then that means all of these corresponding parts are congruent as well. I'm just adding marks of congruency in there. So please go ahead and add marks of congruency in your diagram as well. I'm sorry, in your congruent statements, these statements here. These are all just congruent symbols. Some of them don't look that way, I apologize. Just congruent statements. Well, now I'm going to take all 8 of these statements, all of this information, and I'm going to convey that in my diagram. Do I know if any of these segments are congruent to one another? Do I know if segment AB is congruent to segment BC, or if that's congruent to segment CD? Do I know that? No, nothing in this diagram tells me that. Therefore, we have to make sure that we differentiate between these 4 different pairs of congruent segments. So I'm just going to go in order. Segment AB is congruent to segment EF. I'm going to put 1 mark of congruency on those. That's a pair of congruent segments. And then the next one, BC and segment FG. I'm going to put 2 marks of congruency on those because I need to differentiate between those 2 different pairs. And then keep going on, I'm going to put 3 marks of congruency on those, and then 4 marks of congruency on these. I can't